All right, so now for number 11, we have that vertical posts are to be placed around the outer edge of a children's park. Each post is formed from a cuboid with a right square-based pyramid on top. Compound, that's a lot of buzzwords. It's this guy here. The cuboid part of the post is a machine made such that its width, and hence the width of the pyramid, is exactly 20 centimeters. So this 20 is right there, and the length from the apex of the pyramid, A, or in other words, the tallest part of the pyramid to any corner of the base of the pyramid is 14.6 centimeters. That's this guy here. So for example, from A to C, it's going to be 14.6. From A to B, it's also 14.6. Okay? From A to E as well, from A to D as well. That it? So that is what it means by the 14.6. But, ooh, they put it in bold. It's gotta be important, eh? But this is only accurate to the nearest tenth of a centimeter. The post is shown in the diagram. For part A, we need to write down the upper bound and the lower bound for the possible lengths of the edge AC. So, for part A, we are talking about the number 14.6 to the nearest tenth of a centimeter. See? So we have this 14.6. First things first, what the heck is a tenth? Okay? And this is the sort of thing you can Google and find right away, but here this 4 is going to be your ones, and this 6 is going to be your tenths. Okay? So if it is only accurate to the nearest tenth of a centimeter, that means that your upper and lower bound have to play around with that tenth. Okay? So there's going to be two sort of like veins. See, you're going to have the lower bound, of course, and you're going to have the upper bound. See? So think about the lower bound as the smallest you can get and still estimate it to 14.6 to the nearest tenth. Okay? So, for example, 14, I'm just going to make it a little bit smaller. I'm going to have 5.9. See? So you round it. Do you end up with 14.6? Yes. 14.58. You round it. Do you end up with 14.6? Yes, as well. Guys, what's the breaking point? From 5. From 5 to up. From 5 up, right? You stop rounding up. See? Example, you have 16. I tell you to round it, you end up with 20. You have 15. I tell you to round it, you end up with 20. 14. I tell you to round it, you can't round it, you leave it as 14. See? That is because the breaking point is from 5. Okay? Whatever. We're about to see it in action. It's going to make a little bit more sense now. So, 14.57. Do you round it up? Yes. 14.56. Do you round it up? Yes. 14.55. Do you round it up? Yes. 14.54. Do you round it up? No. And there is my lower bound, ladies and gentlemen. Not that hard, eh? So for the lower bound, it's going to be 14.55. See? For the upper bound, it's very similar, but it's also a little bit, maybe a little bit more confusing. See? So for the upper bound, I'm going to make it bigger just by a little bit. See? So I'm going to have 14.61. Do you still round it to 14.6? Yes. 14.62. Do you still round it to 14.6? Yes. 14.63. Do you still round it down to 14.6? Yes. 14.64. Do you still round it to all 14.6? Yes. 14, and let me make a little bit of space. 14.65. Do you round it up or down? This way round it up. So from here, kapow, it's not. See? So your upper bound is actually technically between the 6.4 and the 6.5. It's just a little bit harder to find which number it is, right? And so here it gets, here it just gets kind of weird, okay? So technically, you would still round it down if you have 14.64, I don't know, 8. You still round it down, see? What if you have 14.649? 14.649, you also round it down, see? And so what is the closest you can get to 14.65 and still round down? Well, you guessed it. It's going to be 14.64 999999999999999. How's my German? All right. So technically, this is the closest you can get and still round it down. See? The problem is that you can't really express that, and you actually have to express it as this guy here. And I know some of you are already telling me, what the fuck? But I'm going to tell what the fuck to you back, because if you look at the answer key literally tells you from 14.55 to 14.65. Okay? It's pretty shitty. Okay? It's pretty shitty, but what I'm trying to express is actually over here, ¿cierto? So here it's like the number right before 65, so you can leave it as 14.64999999. See? And so technically you can leave this as an equality, as the answer key says. You can say, okay, so it's from 14.55 less than or equal to blah 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 14.65. See? So that would be a way to express what I just put. Or you can notice the following. Whenever you put this 999999999, it's technically the same as reaching 14.65. And it's so much so that in the world of math, if you put 0.9999999999999 in your calculator and press enter, it gives you 1. Your calculator basically tells you, dude, it's so close to it, fuck you, it's basically there, it's just 1. See? And this is no different, ladies and gentlemen, if I put 14.649999999999, you still get 14.65. See? And so, point is, you can express it in two ways. You can either do the equality here, which makes a lot more sense to me, or you can say that the lower bound is 14.55 and the upper bound is 14.65. See? So you either say that the upper bound is this and that the lower bound, okay, and that the lower bound is that. Whatever floats your boat, I just really needed to explain the thing where the 99999 ends up being 65. Okay, that is the thing you needed to understand in this exercise. That's that. Okay, so that is lower bound and upper bound. Ladies and gentlemen, we move on. They tell us that point H is the midpoint of BC. Okay, midpoint of BC. Determine the upper bound and lower bound for AH, the slant height of the pyramid. Okay, so now it gets a little bit more interesting. See? First things first, because H is the midpoint of BC, that means the distance from B to H and the distance from H to C is the same. That's why I put a stick on both of them to signify that they're the same distance. And because I know that from E to B, for example, is 20, see? That means from B to H is 10, and from H to C is also 10, see? Now, the upper and lower bound again for AH, see, has to do with the fact that this 14.6 is either, for part A, it's either 14.55 for lower bound or it's 14.65 for upper bound. It's one or the other. And so we need to see how these two sort of versions, okay, are going to affect my calculation for finding AH, okay? And so for AH, again, I'm going to end up with two versions. Notice how here I did lower bound and upper bound. I'm going to end up doing the same for part B. So for part B, I'm going to have the lower bound version, so lower bound version, and then I'm going to have the upper bound version, okay? Now for both exercises, the approach is fairly the same. Because we need to determine AH, the slant height of the pyramid, the key thing here is to think in triangles, okay? So if you think in triangles, you're going to end up finding, well, you can find this one here, see? The one that I'm putting in blue, this is a triangle that you can consider. And so that triangle has points A, H, and C. So I can go ahead and put, for both, I'm going to have A, following my diagram, I have A, then I have H, then I have C. So it's going to be A, H, C. And for the other one as well, I'm going to have A, H, C. And now go ahead and put everything you know about that triangle into your graph. So for the lower bound version, we have 14.55, okay, which is AC, from A to C. So 14.55. Or for the upper bound, we have 14.65. Okay, what else do I know? Well, I applied the midpoint information that they told me. So from H to C, it's 10. It's exactly 10. See? So here's 10, here's 10. How do you know that there's no lower or upper bound here? Well, because they tell you that, as I highlighted before, the width of the pyramid is exactly 20, so I can cut it in two and it'll be exactly 10 and exactly 10. Okay, so that is, there's no cheating there, okay? What else do you know? What else do I know? What else do I know? Well, because it is a square-based pyramid on top, then I have right angles. Well, they actually put a right angle here. Just let me zoom in a lot. They put me a right angle right there. See? So that means I have a right angle right here. Ah, okay, so now this triangle is starting to look very friendly, doesn't it? So, I have a right angle here, I have a right angle there. Guys, what are my tools for right angles? Sorry, for right angle triangles. I have the famous um, Pythagorean theorem, see? And so, Pythagorean theorem, what it tells me, I'm just going to write it here real quick. Pythagorean theorem. I probably wrote that wrong, but I really don't give a fuck. The Pythagorean theorem is a squared plus b squared equals c squared. Okay, and the most important thing for the Pythagorean theorem that you need to keep in mind is that c is the long side. And c, as you can see in the formula, c is alone in the equation. Equation, formula, whatever, see? So c is the long side. If you want to get really fancy in math language, it'll be dear me, the hypotenuse. Okay, in fancy math language, it's hypotenuse. Okay, so C is the long side, and you define C, you define A, you define B. These are all sides. Okay, so technically from here, I need to find X, right? Now, is just focus on the long side. See, for lower bound, which one is the long side? The long side is this one here, 14.5. What is another way to identify the long side? It's whatever is opposite to your right angle. That's another way to find the hypotenuse is whatever is opposite to your right angle. So that means I can write 10 squared plus x squared equals 14.55 squared. See? And if I leave x alone, it would actually be x squared equals 14.55 squared minus 10 squared. And if I go ahead and apply the square root from here to get, the squared alone, so if I do square root here, square root to both sides, that means this goes away with this, and I end up with x equals that. See? So for lower bound, I'm going to have that x equals, we're about to find out, x equals the square root of 14.55 squared, oops, minus 10 squared. See? So that means the lower bound is, I'm just going to write it. See, the lower bound is 10.5689. If I'm not mistaken, let me double check. Yes. And if you want to do significant figures, you count 1, 2, 3. This one to the right, do you round it up or down? It's a 6, so you round it up. It's the same as leaving 10.6. Don't forget units. I think it's centimeters. Yes, it is centimeters. See? So the lower bound is going to be 10.6 centimeters. See? For the upper bound, the approach is literally the same thing. We're going to have that 10 squared plus x squared, okay, equals 14 points. It wasn't 6, it was 6.5. So hey, look at that. We all make mistakes. If you noticed, good job. If you didn't, don't worry. 6.5 squared. So again, x squared equals 14.65 squared minus 10 squared. If I go ahead and apply the square roots, this goes away with this. X is going to equal, let me just show you in the calculator because why not? X is going to equal, kapow, yeah, 10.7061. See? Three significant figures, same idea, 1, 2, 3. This guy to the right, it's a 0, so you leave it as it is. you can write x equals 10.7 centimeters. See? So the this would be the lower bound. Okay, for the for the slant height of the pyramid, and the upper bound would be 10.7. See? So that is just to be super clear, this would be the lower bound, this would be the upper bound, okay? For what? For the slant height. See? All right, so that is for part B. Then they told me that for the post to be safe for children, the angle between the slant height and the base of the pyramid must be less than 22 degrees. We need to show that the post is safe for children and justify our answer. See? So the hard part here is really identifying by what do they mean when they say the angle between the slant height and the base of the pyramid. Okay? So where is that angle? An angle is always going to be between two lines. So that's why they say between. Between what? The slant height, which is this guy here that cuts right across like that. Okay, that's my slant height. And the base of the pyramid. See? The base of the pyramid is basically como just this guy here. See? That is the base of the pyramid. And well, technically, to make an angle in this context, I actually made a small mistake there. The base of the pyramid is this whole thing. See? And so what line is convenient to put there? This line here. See? So you're trying to find the angle that is formed right there. Okay? And so here, there's actually another triangle that can form. Okay? There's a couple ways to think about it. The one that makes most sense to me is to put a triangle that goes like this. Kapow, kapow, kapow. Now, what do you know about that triangle? See? Well, you know the slant height, ¿cierto? That has two versions. You have the lower bound slant height, ¿cierto? For 10.6, and the upper bound slant height for 10.7. So that gives me, let me just redraw this over here, see? It's the same triangle, the same shape. Okay, you have this angle here. I have the slant height, so I have this that the slant height is either 10.6 or 10.7. See? What else do I know about this triangle? There's a 90-degree here because it goes straight up from the apex to the base of the pyramid. And you know that this is 10. Why do you know that it's 10? Because of this 20 here, that means half of it is going to be 10. The other half is also going to be 10. See, it's no different than the midpoint we talked about earlier. That is all I know about this triangle. And I need to find that this angle here with the lower bound or the upper bound, okay, is safe for children because that angle is less than 22. So basically, you need to find this angle here from there. See, from this diagram here, using the lower or the upper bound, whichever makes more sense. See? So we're going to go for both versions, see, using the upper and the lower bound, right? There's a lot of different approaches here. Okay, you can use sine rule, cos, there's a lot of shit that you can do. Okay, I'm just going to use the one that is most direct, but props to you if you find another one. There's a couple ways to do it. You do you, okay? From here, usually, especially if you already have two sides, ¿vale? You can do this thing that is called SOHCAHTOA. See? So notice how in trig, the tools you have are sine, cosine, and tangent, okay, for triangles. The way to remember them, and I don't know why some people don't have it very clear. I guess not all schools show it in depth, but sine, cosine, and tangent, and I guess it depends on your language as well, see? But sine, cosine, and tangent, you can remember sine as so, you can remember cos as ka, and you can remember tan as toa. Okay, this is just the kind of thing you have to remember. SOHCAHTOA, sine, cos, tangent. SOHCAHTOA. It even kind of rings, see? SOHCAHTOA. But remember it, okay? This is the kind of thing that if you remember, it goes a long way. Why? Because for sine, it's a remember that you use sine when you have opposites over hypotenuse. Is that you use cosine when you have adjacent over hypotenuse. And that you use tangent when you have opposites over adjacent. See? So in this case, I have a triangle that looks something like this. Well, of course, I have two versions. Here I have 10 degrees here, then 90 there. I need to find this angle here, see if it's below 22 or not. And here we're going to have the lower bound version, okay? For the lower bound version, you have 10.6, okay? For the upper bound version, we have literally the same case, 90 degrees. A 10 goes here. A 10 points. Actually, fuck, I messed up. The lower bound. Fuck, no, because this is the slant height. Wait, fuck. Yeah, see, yes, the lower bound is 10.6. The upper bound is 10.7. Apologies. I just wasn't sure for a second. So here it's going to be 10.7. Here it's going to be 10.6. Okay, cool. And we're going to find in either of these cases whether this theta angle is less than 22 or not. See? And so remember that SOHCAHTOA is from the perspective of the angle. See? So from the angle, do you have the opposite or hypotenuse? Do you have the adjacent or hypotenuse? What's going on? See? So really focus on this guy here. From the angle of the from the angle of the angle, from the perspective of the angle, see? This 10, what is it? It's the adjacent, see? So this 10 is going to be adjacent, all right? Because it's right next to it. Now this 10.6, you might be saying, okay, that's also right next to it. Aha! But this thing that's also right next to it is what we call the hypotenuse, okay? So that is an important distinction. The hypotenuse is always the hypotenuse, okay? The adjacent can change relative to the angle. The hypotenuse is always the hypotenuse because the hypotenuse is the long side of the triangle. It's what's to the opposite side of your right angle, see? So we're going to apply that for both cases. This is hypotenuse. This is adjacent. Technically, this here would be opposite, okay? Just so you guys know, that is how you treat SOHCAHTOA, adjacent, hypotenuse, opposite, all that shit. See? So for this angle here, we're gonna say because it's adjacent over hypotenuse for cosines here. So right now we're only looking at this guy here. We're gonna have cosine of my angle. Let me do lower bound first. So up here. So cosine of my angle is going to equal adjacent over hypotenuse, so 10 over 10.6. See? Now you need to get this guy alone. See? And so let me make a quick example. Let's say you have 2x equals 4, see? And I say get x alone. What is affecting x right now? X is being multiplied by 2. So to get x alone, you divide. Why do you divide? Because division is the opposite of multiplication, and right now I'm being affected by times 2. You do the opposite, you divide by 2 to both sides. That is how you get x alone. That is how you reach that x equals 2. So in this case over here, it's no different. See? This theta is being affected by cosine. What is the opposite of cosine? Inverse cosine. What is the inverse operation to multiplying? Dividing. What is the inverse operation to cosine? Cosine inverse. So here you can apply cosine inverse, cosine theta, and what the magical thing about that, which I'm about to show, okay, you gotta apply it to both sides. This is no different than multiplying and dividing. You gotta do it to both sides. What cosine inverse does is that kapow kapow. What happens? You end up with theta equals cosine inverse of this whole thing over here. Okay. And so for the lower bound, we're gonna see that cosine inverse. We press second cosine. It's a fraction, so let me just do alpha f1. I mean alpha y equals to reach f1. 10 divided by 10.6. Okay, so my angle here is 19. So for the lower bound, is it safe for children? If my angle is 19.37, yes, it is safe because it must be less than 22. So for the lower bound, it checks out because it's less than 22. See? For the upper bound, it's the same shit. See? So for the upper bound, you're going to do cosine of your angle equals adjacent over hypotenuse. So it's going to be 10 over 10.7. So the process is the same. You do cosine inverse because cosine inverse is the opposite of cosine. It helps you get rid of the cosine, quite literally. So you're going to end up with 10 divided by 10.7. Yeah, you guys get the idea by now. This goes away with this. You end up with just theta. See? Theta angle equals that. So pull up the same thing, just that instead of 0.6, we have 0.7. Here, for the upper bound, the larger number, you end up with 20.839. See? Close enough. If you round it up, if you put all the decimal places and not do the significant figures like it did in part B, you'll notice how in part B I put 10.6. If you use all the values here and all the values there, you end up with a little bit closer to what the answer key says. But hey, if you use significant figures, it's just fine, okay? You end up with basically just the angle of 20.9. See? The conclusion of this is the same. It is less than 22 degrees. The post is safe. So what would you say? You would say for lower and upper bound, we have a safe post because the angle never passes 22 degrees. And then you put the examples of 20.9 degrees is the largest it got. See? There's a lot of different ways to answer this, but basically you have to write a small sentence like it's never bigger than 22 degrees. Keywords, the post is safe. See? Put that somewhere. Justify your answer. How did I know I had to write a sentence? Because it says justify your answer. So basically you just, if you get really, really mathy about it, you would put something like this. 20.9 is less than 22. Okay? And you could even put the other one as well. You can put 19.37 is less than 20.9 is less than 22. They never pass 22. Okay, that's the whole idea. All right, guys. That is for number 11. I hope it helped.